Hello everyone, myself Dr. Nandini Kumari, Assistant Professor Department of Chemistry, Patna Women's College, Patna. Today I am going to discuss about some basic concept about coordination chemistry. In modern terminology, coordination compounds are called complex compound, which is a type of addition compounds. Addition compounds are formed when a stoichiometric amount of two or more stable compounds join together. For example, carnallite. Carnallite is a hydrated potassium and magnesium chloride. It contains two ionic salts in one compound. Both potassium and magnesium ions are present as their chlorides, and the two salts crystallizes together to form an orthorhombic geometry. On the basis of nature, addition compounds are two types: double salt and coordination compounds. Double salts are those salts which lose their identity in solution. For example, more salt is also called hydrated ferrous ammonium sulfate. It dissolves in water and it gives individual identity in solution such as iron 2 plus, sulfate ion and ammonium ion. Another example is potash alum is also called hydrated potassium aluminum sulfate. In aqueous solution, potash alum also gives individual identity of potassium ion, aluminum ion and sulfate ion. Next is the coordination compound. Those compounds which retain their identity in solution. For example, potassium ferrocyanide dissolved in water. Solution does not give the test of iron 2 plus and cyanide ion. Here potassium ion is counter ion, iron is central metal atom and cyanide is a ligand. Next, complex ion. Complex ion may be defined as an electrically charged ion which consists of central metal ion surrounded by group of ions or neutral molecules. For example, hexaamine cobalt 3 ion. Here cobalt 3 plus is a metal, central metal ion and ligand. Cation to which one or more neutral molecules or ion coordinated is called central ion, while the molecules or ions attached are called ligands. Ligands are attached to the central metal ion through coordinate bond. For example, hexaamine nickel 2 ion. Nickel 2 plus is a central metal ion and ammonia is a ligand. Ligands acts as Lewis base, central atom acts as Lewis acid. Next, coordination number. Total number of ligands attached to the central ion are called coordination number. For example, hexaamine nickel 2 ion. Here nickel is surrounded by 6 ammonia molecules. Structure is octahedral. Coordination number is 6. Next is the coordination sphere. Central atom or ion and the ligands attached to it and are enclosed in a square bracket are called coordination sphere. Next, discuss about ligands. Ligand contains one or more than one donor atoms for coordination with the central ion. Ligands are classified on the basis of donor atoms: monodentate, bidentate, polydentate, chelating and ambidentate ligand. Monodentate ligands which donate only one pair of electrons, for example ammonia, water, etc. Bidentate ligand which donate two pair of electrons and tendency to attach to the central metal ion through two donor atoms. For example, ethylene diamine coordinate through both the nitrogen atoms. Polydentate ligands, more than two donor atoms present in the molecules are called polydentate ligand. For example, ethylene diamine tetraacetic acid, it binds through 2 nitrogen and 4 oxygen atoms of the acid group to a central metal ion. Chelating ligands. Bidentate or polydentate ligand attached through 2 or more donor atoms to the same metal ion forms ring structure is called chelating ligand. For example, ethylene diamine. Next is the ambidentate ligand. If a ligand has 2 or more donor atoms, complex is formed, only one donor atom is attached to the metal atom. For example, thiocyanato, in the case of thiocyanato, sulfur atom attached with metal. In isothiocyanato, nitrogen atom attached with metal. Next topic is Bernoulli's theory of coordination. Bernoulli, a Swiss chemist, was the first to formulate his idea about the structure of coordination compounds. The main postulates of Bernoulli's theory as follows. In coordination compound, metal shows two types of valency, primary valency, secondary valency. Primary valency are ionizable and satisfied by negative ions, corresponds to oxidation number. Secondary valency are non-ionizable and are satisfied by negative ions or neutral molecules. Secondary valency is equal to the coordination number and is fixed for a metal. The ions or groups bound to the secondary linkage to the metal have characteristics. A spatial arrangement corresponds to different coordination number. Explain the structure of different cobalt amines on the basis of Bernoulli's theory. Primary valency satisfied by dotted lines and 6 secondary valency are satisfied by ammonia molecules solid lines. Silver nitrate was added to hexaamine cobalt 3 chloride. All the chloride ions were converted to silver chloride. All the 3 chloride ions are bonded by the 3 primary valency. All chloride ions are precipitated. Total number of ions is 4. 3 chloride and 1 complex is formed. When silver nitrate was added to cobalt chloride pentaamine chlorocobalt 3 chloride, only 2 mole of AgCl was formed. 1 chloride ion exhibit dual behavior. Total number of ions is 3, 2 chloride and 1 complex. Next, silver nitrate was added to tetraamine dichlorocobalt chloride. 1 mole of silver chloride was formed. 2 chloride ions exhibit dual behavior, primary as well as secondary valency. Total number of ions is 2, 1 chloride and 1 complex. When silver nitrate was added to triamine trichlorocobalt 3 chloride, silver chloride was not formed because neutral molecule is. Thank you everyone.